Hello everyone, I'm Li Jie, and I'm going to introduce our work on scaling laws of synthetic images for model training for now. Recent significant advances in text-to-image models unlock the possibility of training vision systems using synthetic images. It is unclear, however, how these models behave at scale, as more synthetic data is added to the training set. In this paper, we study the scaling laws of synthetic images generated by text-to-image models for the training of supervised models, for both image classifier with label supervision and clip models with language supervision. We identify several factors, including types of text-to-image models, classifier-free guidance scale, and configurations of text prompts that significantly affect scaling behavior. We conducted the study on 3 text-to-image models, including Stable Diffusion, Imagine, and Muse, and we find it's advisable to use a relatively lower guidance scale compared to the default value used in generation. And to generate images for each specific class, we employ different text prompts. For example, we can have just a class name, or adapt it with templates from Clip, or we can combine it with the captions from ImageNet training images for better diversity. And empirically, the last one works the best in general, as there are more diversity here. Here we show the scaling behavior on ImageNet validation set for various settings. On the left, we show the validation loss, and on the right, we show its accuracy. The results show the loss and data scale follows the power law when the data is less than 4 million, where the validation loss and training set size exhibit a linear correlation in log space. By training the guidance scale, prompt, and text-to-image models, the scaling behavior can be significantly improved, as shown from the blue curve to the orange one. And also, training on synthetic images does not scale as effectively as training on real ones, and typically has a smaller scaling ability as compared here with the red dotted line. In addition to the general analysis of scaling behavior, we also study the per-class scaling ability for each specific category. We find the major reason for synthetic images to underperform real ones is that there could be a concept mismatch for off-the-shelf text-to-image models. Take these 2 categories from ImageNet, for example. The first row here is the reference real images from ImageNet. If you take Stable Diffusion without any fine tuning on ImageNet, you probably will end up with low quality or irrelevant images, as shown here in the second row. So with this concept mismatch, it's really impossible for synthetic images to outperform real ones. As shown here in this figure, the performance goes up quite effectively for real images, but not quite with synthetic ones. However, for some certain classes that text-to-image models are capable of generating, training on synthetic images can indeed yield a better performance. So this suggests as text-to-image models really evolves and are capable of generating more and more concepts precisely, there are potential that training on synthetic images become more preferable in the future. We also investigate the scaling behavior on out-of-distribution validation. In these instances, scaling up synthetic images becomes particularly beneficial and useful. Remarkably, in situations with sufficiently large dataset scales, synthetic images can even outperform real ones, highlighting the potential of synthetic images in bridging significant domain gaps. And here, we investigate the scaling behavior of synthetic data in clip training using Lion 400 million, and show the zero-shot classification performance on ImageNet here. We evaluate the scaling behavior using only synthetic images, or using only real images, or using a combination of both synthetic and real images. And for all 3 scenarios, zero-shot classification loss adheres to the power law relationship when the data amount is under around 64 million. Additionally, the scaling performance gap between synthetic and real is less pronounced than in the supervised classifier setting. Moreover, combining synthetic and real images during clip training can really enhance zero-shot performance, particularly when the dataset scale is limited. Thanks for listening, and please check out our code and model on GitHub for more information.